All right, welcome back. Here is the Chapter 8 practice test that we're going to go through. It covers right triangles, law of sines, and law of cosines. So just a quick refresher before we get started. Um, so for right triangle trig, we want to have our right angle is always going to be C. Say A, B, A is across from A, B is across from B, and C is across from C. We have A squared equals B squared plus C squared. Then we'll just do SOHCAHTOA. So sine of A equals A over C. Sine of B equals B over C. Cosine of A equals B over C. And cosine B equals A over C. And then lastly, tangent of A equals A over B, and tangent of B equals B over A. Those are our right triangles. If we don't have a right triangle, A, B, C across from A, little b is across from little b, C is across from C, then we have two cases. We have the law of sines, and law of sines is for triangles that you have angle, angle, side, angle, or side, side, angle. Those are the three cases that we're going to use the law of sines. This side, side angle is the ambiguous case. So that's the one we have to worry about, where we have 1, 2, or no solution. So with the law of sines, it's sine A over A equals sine B over B, which is the same as sine C over C. Same triangle. If we are given different information, we're going to use law of cosines. So with the law of cosines, that is for side, angle, side, or side, side, side. And that's one of three cases. It's like the Pythagorean theorem, a squared equals b squared plus c squared minus 2bc cosine A. Likewise, we could switch it up. B squared equals a squared plus c squared minus 2ac cosine B. Or thirdly, c squared equals a squared plus b squared minus 2ab cosine C. So using these three, we'll have right triangles, or we'll have law of sines, or we'll have law of cosines. So jumping right in, we're given this right triangle. It says find the exact value of the 6 trig functions of theta. Be sure to all your answers are in correct radical form. So if it wants exact answers, we're not going to be typing into the calculator at all. So we're first going to look at, here's theta down here. I want to find the opposite side. So I'm going to start with the Pythagorean theorem. So let's just say x squared plus 10 squared equals 25 squared. So that's x squared plus 100 equals 625. Subtract 100 from both sides, we get x squared equals 525. Square root of both sides. So we have x equals, and 525 has a 25 in it. There's 21 25s in there. So 5 root 21 when simplified. So now we're asked for the 6 trig functions. So we want sine of theta equals x over 25. So 5 root 21 over 25, which simplifies to root 21 over 5. We have cosine of theta, which is 10 over 25, which is 2 over 5. We have tangent of theta, which is opposite over adjacent. So that's 5 root 21 over 10, which is root 21 over 2. So now we can switch it up. Cosecant is 5 over root 21. So that's 5 root 21 over 21. We have secant of theta, which is 5 over 2. We don't have to rationalize that at all. And we have cotangent, let's write that right, cotangent of theta, which is 2 over root 21, which if we rationalize that, that's 2 root 21 over 21. Next up, number 2, solve the right triangle using SOHCAHTOA. So first off, if A is given to be 27 degrees, we can find angle B just by saying b equals 90 minus 27 degrees because those are complements. So 90 minus 27 is b equals 63 degrees. So always find the angle first of the right triangle. Next up, we can just do a simple trig. We want to find little b, we want to find c. So what I want to do is we can either do tangent of 27 or the tangent of 63. I'm going to say the tangent of 63 equals b over 7, opposite over adjacent. So now I'm just going to multiply both sides by 7. So 7 times the tangent of 63 degrees equals b. We're going to type that into our calculator, and we're going to get b equals 13.74 inches, because that's our units. So now we can find c. We can either use the Pythagorean theorem, or we could do another trig. I'm going to do trig because it's more exact. I'm going to say the sine 27 degrees equals 7 over c. So we're going to cross multiply. So c equals 7 over the sine of 27. We type that into our calculator and we get 15.42 inches. Moving on to problem 3. For each one of these, I'm going to draw a picture on a separate sheet of paper just because I want to show a little bit more work, which requires a little bit more room. So it says draw a picture for each and determine which case it is. So remember what we said at the beginning. We're either going to use law of sines or law of cosines, depending on what we've got. So I'm going to draw a picture. I'm going to zoom in just a little bit. Here's our triangle. It says angle A is 100 degrees. So that's 100. B is 16 feet and C is 20 feet. And I want to find the remaining pieces. So find B, find A, and find angle B. Oh, and find side A. And I'm guessing that should be side angle C. So we'll just go with that. So here we have side, angle, side, side, angle, side. So we're going to do the law of cosines. And if it's side, angle, side, we're going to do this twice. So we're going to find side A first. So we put a squared equals b squared plus c squared minus 2bc cosine A. So I'm just going to start plugging in. A squared equals b squared, so 16 squared, plus 20 squared, minus 2 times 16 times 20 cosine 100. Now, all I have to do is type this into my calculator. So if I zoom in just a little bit so we don't have so much glare, I'm going to type in 16 squared plus 20 squared minus 2 times 16 times 20 times cosine of 100. I hit enter. I get this, and I'm going to take the square root of that answer. So A is 27.7. So A equals 27.70, and the units on this were feet. So let's zoom back out a little bit. Okay, so this is 27.7. I'm going to find angle B. So angle B, we're going to have the formula b squared equals a squared plus c squared minus 2ac cosine of b. So we already know most of these. This is 16 squared equals 27.7 squared plus 20 squared minus 2 times 27.7 times c, which is 20, cosine b. So now the rest of this I'm just going to do on the calculator. So let's zoom in again. So I have 16 squared minus 27.7 squared plus 20 squared divided by -2. Let's put this in parentheses just so I don't mess it up. Answer divided by parentheses. -2 times 27.7 times 20. Now I want the inverse cosine of that, so I'll go to inverse cosine of that answer, hit enter, and I get 34.68 degrees. Let's zoom back out. B equals 34.68 degrees. To find C, I do 180 minus 100, which is 80 minus 34.68. If I do that, and I'll do that off to the side, that's 180 minus 100 minus 34.68. So angle C is 45.32 degrees. Moving on to the next one. So looking at number 4, the info that we're given is side A, angle A, and side B. So I'm going to draw my picture. Say A is down here, B is up here, C is here. Little a is 3, angle A is 10, and side B is 4. So if we look at these, I have side, side, angle. So if I have side, side, angle, I'm going to do the law of sines. And if I notice, this is the ambiguous case. So I might have 2 solutions, or 1 solution, or no solutions. So first things first, I'm going to find angle B. Find angle B first. So I'm going to say the sine of 10 over 3 equals sine B over 4. So to solve for this, multiply both sides by 4. So I get 4 sine 10 over 3 equals sine B. So B equals the inverse sine of that quantity. So I'll go over to my calculator. I'm going to type the inverse sine of 4 sine 10 divided by 3. Hit enter. And I get B equals 13.39 degrees. So that's an answer. So I have at least 1 solution. Now I'm going to check for two solutions. So what I do is I take 180 minus B. That could be my second solution. We call that B prime. So 180 minus 13.39 is 166.61. Now, check. Does that work with my other angle? Is 10 plus 166 less than 180? It is. So this actually works out, and we're going to have a 2-solution problem. So I'm just going to split this down the middle. If my angle B is 13.39, then my original C is going to be 180 minus 10 minus 13.39. So C could be the largest angle, and C would be 180 minus 10 minus 13.39, which is 156.61. But if B prime happens to be the largest angle, then C prime would be 180 minus 166.61 minus 10, because that's B prime and that's still A. So if it's 180 minus 166.61 minus 10, I'm just doing the calculator work off screen, C prime is 30.39 degrees, which is an incredibly small angle but it's still an angle. So then I still have to find side C for both of these. So that's the case. We're going to use this. We're going to say sine of 10, which is A, over 3, equals sine of 156.61 over little c. So if we multiply this out, we get c equals 3 sine 156.61 over sine 10. So if I type that in, 3 sine 156.61 divided by the sine of 10, hit enter, I get c equals 6.86. And I believe the units are in feet, so that's feet. If I do this for c prime, this is big C prime, so same thing, sine 10 over 3 equals sine 3.39 over, let's say, little c prime. So if I solve for little c prime, then I get 3 sine 3.39 over sine 10. So just type that into my calculator again, 3 sine 3.39 divided by sine 10. I get c prime equals 1.02 feet. So here, if I have two solutions, it's because B originally was these three things. So we have B, B prime, C, C prime, and little c prime. All right, let's try the next one. Last problem on the front page. Again, it gives us the information, so let's draw a picture for this. That will help out. It says A is 100 degrees, so it's looking just like the first one. A, B, C. Say that's 100. Little b is 1, and side A is 4 inches. That's 1 inch. So let's zoom in just a little bit. Again, I have side-side angle. So that is a law of sines problem. So we're going to start off, we're going to find angle B first. So it's sine of 100 over 4 equals sine B over 1. So if I multiply both sides by 1, that stays the same. So B is the inverse sine of sine of 100 over 4. So I go to my calculator. I'm going to type in the inverse sine of sine 100 divided by 4. And I get B equals 14.25 degrees. So that gives me a solution. So I need to check for a second solution. So by doing that, I'm going to say 180 minus 14.25 is B prime. So B prime would be 165.75. But looking at this, if this angle is 165 and A is 100, these already add up to over 180. So we're not going to have a second solution. So this is only one solution. So with one solution, we already have B, so I can find C from here. C is 180 minus 100 minus 14.25. So if I type that in, I get 180 minus 100, which is 80, minus 14.25. So C equals 65.75 degrees. There's B. To find little c, we're going to do the sine of 100 over 4 equals the sine of c, which is 65.75, over little c. So again, If I cross multiply, I'm going to get little c equals 4 sine 65.75 all over sine 100. So then I go to my calculator, type that in. I have 4 sine 65.75 divided by sine 100. I hit enter. I have little c equals 3.70 inches. So there we go. There's B, there's C, there's little c. Moving on to the back side, we're going to have a couple story problems on the test. So hopefully I can give you the picture for each. So given the picture on the right, how wide is the river? So we look at this. This is a right triangle, so we're going to do right triangle trig. Let me zoom in just a little bit here. I want to find this side. If I have my angle, which is 25, and I have the distance between C and B is 50, so I'm going to use the tangent. So the tangent of 25 degrees equals x over 50. Multiply both sides by 50, and let's get that on the screen. So x equals 50 tan 25, which if I type that in, I get 23.32 feet. So that's how wide the river is. Pretty straightforward, pretty easy. Moving on to the next one. So, number 7. Given this picture, I want to know how far away these two houses are. I want to know the distance from A to B. So you can see that we're given angle, side, angle. So I should be able to do the law of sines. So first thing, I should probably find this angle B up here. So B is 180 minus 35 minus 50. Type that into my calculator. 180 minus 35 minus 50. That gives me 95 degrees. So that's 95 degrees, and that allows me to do the law of sines. So if I want to find x, or let's say c in this case, I'm going to say the sine of 50 over little c equals the sine of 95 over 100. So to solve for c, I get c equals 100 sine 50 over sine 95. So if I type that into my calculator, I get 100 sine 50 divided by sine 95. I get c equals 76.90 feet is the distance between these two houses. And I'm done. Last problem is a story problem, and it's given a picture of Wrigley Field. The distance from home form, that should be from, I'll fix that for you guys tomorrow. Home to the fence, dead center, is 400 feet. How far is it away from the fence to third base? So I am looking for, in this picture, I want to know the distance, hopefully this shows up just a little bit, between these 2 points. And what I know is that from dead center to home is 400 feet. Let's see if those colors show up any better. Not really. The only other thing that I know is that from third to home is 90 feet. The other thing that's implied that you should know is each of these angles in the base is 90 degrees. So if we go from just to dead center, this is 45 degrees. This is 400. This is 90. If I redraw this, this is 90 feet. And I want to know the distance here. So if you look, I have side, angle, side, side, angle, side. So I want to use the law of cosines to find x. So let's just zoom out just a little bit. I want to use the law of cosines. So that's going to be x squared equals the other two sides squared, so 400 squared plus 90 squared, minus 2 times 400 times 90 times the cosine 45. Now all I have to do is type this into my calculator. To expand this out though, 400 squared is 160,000. It's 16 with 4 zeros, plus 8100 minus 2 times 400 times 90 times the cosine of 45, which is root 2 over 2. So these two cancels out. So that's 36, 1, 2, 3, root 2 equals x squared. So if I type this into my calculator and I take the square root, I get x equals 342.33 feet. Hopefully these make sense. If you have any questions, let me know tomorrow, and good luck studying.